All right. We'll pretend that didn't just happen. Okay, so one more time for those of you in the room. Where we're headed with this is you are going to be solving sine functions or inverse sine functions, okay? And as you know, a sine curve just keeps doing this, right? So there are all kinds of places where it hits a half on its way up and back down, and then goes into negatives, hits a half on its way up and back down, and it's going to keep hitting a half. Every time it goes up, it's going to hit it twice. And you're going to be an infinite number of solutions, and what we're going to do is figure out a way to write a formula representing that. And we did that last year. Hopefully that won't be a big deal. It's really not. I think you're going to remember when you see it. This is very similar to this one, except I've limited you. And because I've limited you, you're not going to have as many answers because it's not going forever to the right. So you're basically going to look, well, in 360 degrees, what happened? And you remember that a sine curve takes 2 pi to complete the whole period, right? So it's going to hit 1/2 there, there, and then not again. Now, it would depend on what the interval is. If I stretch it out to 720, it might hit a couple more times. But if you understand how to do this, which you will in a second, or I'll remind you, this will make sense too. But this is different. This is an inverse sine curve. And as you know, I mean, are there differences between a function and their inverse? Yeah, because I've switched the x's and y's on all of them. I mean, you've seen that. What's an exponential function when you do an inverse? What's it become? A logarithm. Totally different looking graph. Well, a sine curve that looks like this, when you do the inverse, now it's doing this, up and down the y-axis. But the problem with that is, if I do this up and down the y-axis, is it going to pass the vertical line test? It's not. So what mathematicians decided to do is they said, well, we've got to make it reflected over that y-axis. I mean the y equals x-axis, because that's what inverses do. So when they take this sine curve and they reflect it over the y equals x-axis, now it's not a function. Well, let's fix that. And the way they fix it is that they crop it and they keep only a section that would pass the vertical line test. Well, when they crop it, that's what gives this limitations. So even though I'm thinking the same thing when I look at that and when I look at this, or even when I look at that, I'm thinking the same thing. What angle has a y value on my unit circle that's a half? That's what I'm thinking here. What angle has a y value on my unit circle? It gives me a half, except I'm limiting those angles. Well, this is saying what angle on my unit circle has a y value that's a half. Saying the same thing, but this has a limit to it, just like this one did. But it's a constant limit. It never changes with inverse sine. It's always, and you'll see in a second, negative 90 to 90. Now, when you get to inverse cosine, it's got a different limit. Inverse tangent's different. And you got to memorize those three. And it's not that big of a deal. And you might remember this from last year because we've gone over this a little bit. But we're going to go a little bit more into depth this year. So I want to talk about why that inverse function is what it is, but you don't have to memorize these graphs. Okay? So looking at the graph of this, I'm just going to try to sketch it out and help you see it. Does it make sense that if I had continued this sine curve, it would have just kept going on and on and on and on, right? Well, look over here. I'm going to sketch in the sine curve. Here's 3.14, which would be pi, right? That's like 180 degrees. And there is about, if this is 1.57, this would be maybe about 1. So if this had been a sine curve, it would have looked something, and here would be your negative 1. It would have looked something like this. Are y'all tracking with me? That would have been a sine curve. And it would have gone, there was negative 3.14. And it would have just continued on like this. Y'all with me that that's a sine curve ballpark? Does it make sense right here that if I want the inverse of a sine curve, that I want it to be reflected about the y equals x? And if that's 1 and that's 1, I know that these are different kind of units here because I'm using trig units. But can you see that 1, 1, 2, that's about 2. That would be the y equals x axis. Doesn't this kind of look like a mirror image? The only difference is I cropped it here and here. And the reason why I did that is if I don't, it wouldn't pass the vertical line test, would it? Are you seeing that? So with invert, you don't have to know how to graph it. And you won't need to know how to graph it in AB Cal at all. I don't know, maybe Helmers makes you know something if you take BC, but I know in AB you don't. So don't worry about missing out. I'm not cutting you some slack on not having to graph these. And I actually cannot think of a time when I would need it. And if you ever needed it, it's probably a calculator question where you could just literally graph inverse sine of x, type in your calculator, and you'll see that little graph right there. Okay? So what they did is they said, well, we got to crop it. If I crop it here and here, 0 to pi, it wouldn't pass. So they chose pi over 2 and negative pi over 2. And they kept that little section. So that is why inverse sine goes from negative pi over 2 to pi over 2. Right here. Does that make sense? That's why you're limiting it. So when you start looking here, it's different than this, but it's kind of the same. Because if I'm talking about a sine equation, I am signing what? You sine a what? Say it. An angle. Yeah. You take the trig function of angles, right? And the trig function of an angle gives you a what? Think about it. Sine of 30, tangent of 60. A what? Oh, and a fraction made up of what? Yeah, but what do they come from? True. All true answers. I'm not asking good questions. They're what?
Coordinates on the unit.
Okay, but in real life, what are they?
Numbers.
What a trig is all about looking at what? Triangles. So these are sides of triangles, right? And the unit circle helps you see that better and organize it better so you don't have to think as much. But you know that sine is the opposite side over the hypotenuse, right? Tangent's opposite over adjacent. So these, you always sine angles. And what you get are I call them ratios. Sometimes I call them values. You can call them decimals. Sometimes they're decimal. But this represents the ratios of the two sides of that triangle. Does that make sense? Well, if I inverse sine it, now what am I inverse sining? Because remember, to inverse sine something, you're switching the x's and the y's, right? So now what is that? Now that's the ratio. So now that is the ratio of the two sides, or our value. Some people call them values. It's the ratio of the two sides, and you end up getting what? The angle. It's important that you understand that. So if I ever see an inverse trig function of blah, that blah represents the two sides of the triangle that are in question. And your simplified value that it's equal to is whatever angle makes it true. But that angle that you find has a limit. And the limit for inverse sine is negative pi over 2 to pi over 2, or negative 90 to 90. Okay? That's what you have to remember. Now, do you have to remember this graph? Absolutely not. Here's what you have to remember. That when you're dealing with an inverse sine, what does the x represent again? The angle or the ratio? With an inverse. That's the ratio, right? Because you would sine an angle. You inverse sine the value or the ratio. So the value or the ratio there, okay, that you're inverse sining, well, what's sine have to be? Think about triangles. If sine is like opposite over hypotenuse, can that ever be bigger than 1? If the hypotenuse is on the bottom, isn't the hypotenuse always the biggest? It's possible that if you shrink it, if you go all the way up, they're the same. But think about the sine curve. The sine curve only goes as high as what? 1 and down to negative 1. So these ratios or values are always between negative 1 and 1. Which means if I ever said, hey, what's the inverse sine of 3? What are you going to say? D&E. That can't happen. How could the opposite over the hypotenuse be 3? Does this even make sense? Opposite over hypotenuse. No, that doesn't make sense. So the values have to be between -1 and 1. But what does the y represent? And the angles have to be between what? Based on the picture I just showed you. -90 to 90 or -pi/2 to pi/2. For our work, we deal mostly in angles. So -90 to 90. That's what you have to know. So back to that very first problem I was talking about at the beginning where you had the inverse sine of 1/2 or the sine of theta equals 1/2. If you're solving that inverse trig function. Now guys, there's a difference between if I start with the sine curve, you think sine curve. If I start you with inverse sine, you think -90 to 90. My answer has to be in between there. Now this I guarantee. If I were to have talked to you 3 years ago, if I were to come up to you and say, hey, do y'all understand negative numbers? You'd be like, yeah. And I'd say, okay, is 300 degrees between -90 and 90? Every one of you would have went, no, 300 is way bigger than 90. Yet for some reason, and I know, I can get it, because 300 degrees is right there on the unit circle, and this is 90, and this is -90, for some reason now people go, yeah, 300 is between -90 and 90, but it's not, is it? 300 is this way. It's well past 90. But there are coterminal angles that lie in that same spot, right? Now remember how we talked about spinning on the interstate with my car, right? 720 degrees is not 0 degrees. It's different. But when you're dealing with trig functions, it's in the same spot, so it's okay to use those angles interchangeably. So 0 is not 360. I'm sorry, 0 is not 2 pi. 0 is not 360, but it does act with trig functions that way. So I cannot use 300, and what can I use in its place? -60. And I'm guessing if I were to say, hey, is -60 between -90 and 90? 3 years ago, you would have said yes. Now, you might not have if you were really struggling with negative numbers, but I'm guessing you would have. So don't forget what you already know, okay? Being in that place, that's just one way to name that angle. You got to make sure your answers are in the right spot. So if I'm dealing with an inverse sine, and I'm going to go back to that problem in a second, like a half. If I'm dealing with an inverse sine and you look at the unit circle, and the unit circle, you look down there and you see 300, you can't use that as an answer on an inverse sine because it's not in that interval. You have to subtract 360 or add 360 or do whatever you have to do to make it lie in that interval to answer. Because inverse sine is a completely different graph than the sine curve. Are y'all seeing that? Every year I really get adamant about this. And every year, people, this is the thing people miss on this test. And they miss it over and over and over again. And you just have to make sure you understand it's a totally different function. Even though you're thinking to find the location of it's kind of the same. All right, and then real quickly, I'm not going to beat up all the other ones, but just to walk through them very quickly. And again, you don't have to know how to graph these. But right here, cosine, you know the cosine curve starts high, goes down and up and down and up and down and up forever, both ways, right? There's no limits to it, okay? And I only showed you this because I was trying to make a little parallel here. So right here, if I was graphing this, there's 3.14. It would do something like this. And then get down to -1 right there, and then it would come back up and be up to +1. And you can see, if that's 1, 1, there's the y equals x, right? Can you see that it's a mirror image? But listen, if I made the inverse cosine curve do this, what's the problem with that? Does it pass the vertical line test? Now, I'm sure mathematicians back in the day went, well, let's keep it from -9 pi/2 to pi/2, -90 to 90, and that's what that is. That's a half a pi. But what's the problem with keeping it the same as sine? It still wouldn't have passed the vertical line test. So they switched and went, we'll go from 0 to pi, or 0 to 180. And that's why inverse cosine is defined that way. Are y'all seeing that? Okay, so right here, if you're ever given an inverse cosine problem, again, what does that x stand for? You inverse cosine what? Ratios or values. And what your answer is going to be is a angle. Unlike if I gave you this, if it's cosine, I take the cosine of a what? An angle, and I get a ratio or value. So even though the variables might look the same there, you have to think about what kind of function it is. All right, so and then that's inverse cosine. We'll talk about these, and I'll write all that stuff down in a second. And then back to inverse tangent. Inverse tangent, if you think about this part right here, if you were to reflect it over the y equals x-axis, now it looks like this. Okay? Now, in real life, if I had all the sections, you would have had all kinds of layers of this, wouldn't you? But then it wouldn't pass the vertical line test. So what did they choose to keep it between? What is that? Half of a pi, so pi over 2, negative pi over 2 to pi over 2, except one difference. Inverse sine was equal and in between. But because these are asymptotes, it never hits them, so they're just not equal. So it's still between negative 90 and 90, but not between negative 90 inclusive. So it would just be inequalities as opposed to equality and inequalities. Y'all see the difference? But it has the same range. And the other thing is, do you remember how on the cosines and the sines, the ratios were always between what and what? Negative 1 and 1. That's also true with sine, right? The ratios were all, the x's, the ratios were always between negative 1 and 1. But look at the tangent. And by the way, remember why that's true? The ratios are between negative 1 and 1 because to be bigger than 1, the opposite side would have to be bigger than the hypotenuse, and that can't work. But what about a tangent? A tangent is defined as opposite over adjacent. Can that be bigger than 1? Sure, that could be 3 and 1, 1,000 and 1, 1,000,000 and 1, 1 and 1,000,000. I mean, it could be all kinds of things. So on inverse tan, the actual x's, if you look at them, the x's, which are the ratios, they could be anything. They go from negative to positive infinity. But the angles that you get out of it, the y values, negative 90 to 90. So I'm going to write all this down. This is usually a test question. You're going to have to, I'm going to give you something like this and say, hey, but I'm going to write angle and y so that you have to know which one's which. The x stands for what on an inverse trig function? The values of the ratios. So the values on an inverse sine can only be from what to what? Negative 1 to 1, good. And the angles between negative 90 and 90, or negative pi over 2 and pi over 2. And you'll notice here they're equal. Because they do actually hit, they do actually hit those 2 points. Now, right here, what are the values? The actual ratios. Like sine, the hypotenuse is on the bottom there of cosine. And the hypotenuse is always bigger, so that keeps it from being bigger than 1. So the values, again, between negative 1 and 1, which means I can't ask you what inverse cosine of 2 is. You'd say, I can ask you, but you would just say DME. Can't do that. I mean, you could try to draw a triangle and say, all right, the adjacents do the, wait a minute, what the heck? I mean, it won't make any sense, right? So negative 1 to 1, but the angles on inverse cosine are what? 0 to 180. And then I'm going to show you how this plays out. And then finally, inverse tan, the values there, the opposite hypotenuses, the x's, they could go from what to what? Negative infinity to infinity. But the angles are what? Negative 90 to 90. And you'll notice they're not equal on this. Right? Because of the asymptotes. So, it says, why do we have to limit the angles of the inverse trig functions based on what we just said? To make them function, so they'll pass that vertical line test. Good. Now let's go through, you got this written on your paper, so I'm going to scroll up and erase this. But let me show you again how this plays out now. Number 5. I'm giving you what seems like the same question written 3 different ways. This one is saying, hey, take the sine curve, which goes forever left and right, okay? And find the angles where it would be equal to a half. Now I'm going to use my unit circle to help me with that. I'm going to say, all right, the unit circle, where would the sine, I'm going to be looking at what variable in this unit circle? The y. So where would I have a positive 1/2 y value, which means up a little? Well, I could go up a little there, or up a little there, a half, right? So those two angles would be a good place to start. And those two angles are 30 and 150. Now I could also look at the sine curve, but I'd rather look at this. The sine curve, you can see it hit at 30, and then at 150, and then it goes all the way down through the negatives before it hits again. But right here, it's easier, I think, to go, oh, 30 and 150. Now, if I just write 30 and 150, where did I go wrong? I didn't put any limits on this like I did here. So if this sine curve continues forever, where else am I going to hit? Not just at 30, but also at 3, what? If this is 30, I'm going to have to go all the way around another 360 to hit 390, and then another 360 to hit 750, and then another 360 to hit 1110, and I'm going to have to keep going and going, or I could go the other way. I could go this way and hit a negative 330. So how did we do that last year? Do you remember? Yeah, I just say, okay, it's that angle or any other angle that's 360 degrees bigger or smaller. And I say that by putting an n there. And n stands for an integer. So if n was 0, then you just have 30. If n's 1, you have 390. If n's 2, you have 750. If n's a negative 1, you have negative 330. It gives you all the other coterminal angles. And that's how I figure all those extra ones out. And then I do the same thing here. And you can say minus if you want, it doesn't matter, because it still gives you all of them, because n could be any integer, positive or negative. Now, here, I'm doing the exact same thing. In fact, I could even write these formulas to help me. I could say, okay, the formulas that are true here are still the same formulas, right? They're still the same, and you may or may not want to do this, depends on that, you will see eventually. But I can't tell you that all of them work, because does 30 plus 360 actually work? Does 390 work in this interval? Does 30 minus 360 work in this interval? So from that equation, what worked in that interval? Just the 30. And same thing from the other one. I can't add or subtract 360 and get any more in this interval. So I keep just the 150. Now here's where people start getting in trouble. They get in their head that this interval means that there's only 2 angles, and they just start writing 2 every time. And the book doesn't do you any favors, because most of the time the book uses that interval as well. But I'm going to change it from negative 180 to 180. So like, what if this was negative 180? How about negative 360 to 360? Now what do I have to include? The 2 negatives, if I subtract the 360 and get a negative 330, I'd throw that in there. If I subtract the 360 and get a negative 210, I'd throw that in there. So it all depends on the interval. If there's no interval, give me formulas. If there is an interval, you're welcome to use that. You're welcome to, but only write the answers that are true in whatever interval you're given. Are y'all seeing that? Now the last one, same initial thinking, but you have to think about this was started as an inverse sign. And if I start you out as an inverse sign, you have to remember there is a limitation on there built into the problem. There's one of these built in, and what is it? Negative 90 to 90. So initially you're going to go, oh, inverse sine. My angle has to be between negative 90 and 90. It is built into the problem. So I come back to the same formulas and I go, well, it's not, I mean, it could definitely be 30, couldn't it? Because definitely 30 is right in the middle of that. It's smaller than 90, it's bigger than negative 90. So definitely 30 degrees works. But does 150 work? No. Are y'all seeing that? It's just a built-in interval. Now I know some people look at this and go, yeah, but Mr. Hurry, go back to 5a. On 5a, wouldn't you, to solve this, do inverse sine of 1/2? You can, if this was like not a unit circle problem that I knew about, and I needed to type that in there and say it was an ugly decimal that represented the ratio of the 2 sides. And you're like, I don't know what angle that is, it's not special. But I could do that to get my answer. But did I start you with the theta? I mean with the sine curve, or did I start you with an inverse sine curve? Sine. So you think like it's a sine function. We'll talk about how to solve those later, even though we did do that last year. We'll do that in a day or two. Are y'all with me on this? but you have to make sure you understand these limitations. So as I'm walking you through some of these, and we'll do what we can before this bell rings. 8:50. All right, so let's take a look at these. What's wrong with 6, 7, and 8? Tell me, what's wrong with 6, 7, and 8? Is there anything wrong? I'm not going to get done when I want to get done. Okay, so right here, let's walk. I'm sorry, you didn't answer my question, but what did you say? That's right. Like, if you think about this, where is the y value? What angle has a y value that goes down a lot? Down a lot would be that angle or that angle on the inner circle. That looks like, what, 240 or 300? Now, I could start out with those formulas if I wanted. But because it's an inverse sine, I know it's got to be between 90 and negative 90. So there is absolutely no hope for the 240. And the 300's in the right place, but with the wrong name. Are y'all seeing that? So if it's in the right place, but with the wrong name, how do you fix it? And how do you change the name? Subtract the 360. Because remember, there's all kinds of coterminal angles that are in that spot. That's just not the one. It's between negative 90 and 90. So if you write this, you're missing it. Because it's not in the right, clearly, and is that between? Really? That's smaller than 90 and bigger than a negative 90. 3 years ago, you wouldn't have said yes. But this negative 60 is in that interval. So you're going to change that 300 to a negative 60 and go with it. How about this one? Inverse cosine, root 2 over 2. Inverse cosine means x. Where do I go positive root 2 over 2? Well, that would occur there and there, which would be what? 45 and 315? Or possibly negative 45 if you think about it that way. But inverse cosine, where is it defined? 0 and 180. So there's no way either of those can work. Toss it out. But 45 is in that range between 0 and 180. So I keep this. How about this? Inverse tangent. Hopefully you watched and paid attention to that and memorized those tangents. Where did I say inverse tangents? Or where did I say you got root 3 on a tangent of an angle? Which angles had the root 3s, not the root 3 over 3s?
31, 52, 10.
The root 3s were the tall ones. The root 3 over 3s are the small ones. I mean the small reference angles. So 60, 120, 240, 300. Are y'all with me? So where would it be negative? Not at 60 and not at 240, but at what? 120 and at 300. But wait, where is inverse tan defined? Negative 90 to 90. Y'all tracking with me? And if it's defined between negative 90 and 90, does this have a hope? No. Get rid of that. Does 300 have hope? Yes. It's in the right place, but with the wrong name. So what do? You change it to negative 60, and now it's going to work for you. And guys, that's why all of this stuff, this is the exact same question you had yesterday. You had a whole page of them. Except yesterday, you had this. Cosine theta equals negative 1/2. It's the same thing, except this is asking this with a limitation built in. This is the same thing as this with a limitation built in. So instead of having two answers like you probably did for most of that work yesterday on the backside, now you're going to have one answer because it's limited to just that one section where that might occur. Is that making sense? Okay, I'm hoping it does. Please do your work and check your work on this section, and then I'm going to start this next part, and sadly I may not finish, which means I may have to make a little small mini video to tack on to tomorrow's work, or I may even just tack it on at the end of the day, but I'll figure something out. So I'm going to go through this, and I'm going to jump to this composite stuff. So I'm going to start out with number 7. All right, this is composite trig function. Now, I think you guys can probably do this problem right now, because what is this problem saying to you? What would you do first? Do what? If you were given this, what would you do first? What does PEMDAS tell you to do first? So go to the inner part of the parentheses. Is there anything you can do to this? Yeah, that's an inverse sine problem, right? So if I'm looking at just this part, I'm saying what? What angle has a y value of that on the unit circle, but is between what? Negative 90 and 90 because it's inverse sine. Oh, by the way, if you didn't know what arc sine means, arc sine and inverse sine mean the same thing. Arc tan, inverse tan, that means the same thing as an inverse sine. So let me just draw a little picture of that real quick. Where would I go down? Square root of 2 over 2 would be down where? 225, 315. Which one of these two is in between negative 90 and 90? 315, but it's the right name, but the wrong value is, the right place, but the wrong name. So what are you going to use in place of that since it has to be between negative 90 and 90? Negative 45. So I'm going to replace this with negative 45. Now, what's left for me to do now? I drop down the cosine. Now I've got a cosine problem. So I asked myself, what would be the cosine of negative 45? Well, what's negative 45 look like? It's right there, right? What's the cosine of that angle? That would be the x value right here. What would that be? Positive root 2 over 2, and you're done. And problems like 7 and like 8 and like 9, that's how you deal with them. They're unit circle values, they're pretty familiar. But here's where it gets a little tricky. Come down here to number 10. Does this make sense so far? Now come down here to number 10. What does this say? Somebody tell me in their own words, what am I asking you for on this inner part? What am I looking for? This is a value, so the inverse sine of a value is going to give me a what? So what angle has a sine value of 3/7? I have no idea. That is not a unit circle value. Now my calculator could tell me an approximation, but I don't know. But here's the great part. If I stopped it right now and you didn't have a calculator, you would not be able to know this. But I don't need to know it. What I need to know is what of that angle? The cosine of it. So I don't need to know the angle, I need to know the cosine of the angle. Isn't that really what I'm looking for? Well, draw a picture. Check this out. Inverse sine of 3/7. If it's an inverse sine, where do you know the angle is going to occur? Negative 90 to 90? So right now you know it's going to occur here. But if both of those are positive, where would the triangle be? It would have to be here. So just sketch a picture. It doesn't have to be a good one. So my angle would be right there. And what do I know about this angle? The what and the what. What does this represent? If it's inverse sine. The opposite and the hypotenuse would be 3 and 7. Does that make sense? Because the sine of that angle would be 3/7. All right, that makes sense. Now, I don't know the angle, do I? But I don't need to know the angle. I'm taking the cosine of that angle. That I can do because I know Pythagorean theorem. The cosine of the angle is just this x over the 7. Can I find that x? 7 squared equals 3 squared plus x squared. 49 and 9, so 40 equals x squared. X equals root 40. Or 2 root 10, right? So x is 2 root 10. Can you now tell me the cosine of this angle? Bam, 2 root 10 over 7. Who knew? And I never found the angle. Yes?
So you did the sine is opposite over hypotenuse, but how did you get that since it was inverse?
Because what does this mean? This right here means the inverse sine of a value gives me an angle. So there's some triangle out there that has an angle where the opposite and the adjacent is 3/7. That's what that's saying. So, and I know that it has to be in the first quadrant because if it was in the second quadrant, it would be negative, right? And it has to, the fourth quadrant would be negative, and it has to be in the fourth or the first because that's where inverse sine exists. Negative 90 to 90. Walk through another one real quickly. right here, this says inverse cosine's value is -2/3. Now, where would inverse, now, and what is this going to give me? If I was able to calculate it, that would give me a what? An angle. And I'll never find that angle, but I could find the tangent of it. So I'm going to draw a picture. Now tell me, where is inverse cosine exist? It exists here. Where do you think it would be negative? First or second quadrant? Second. So I'm going to sketch a quick picture right there. There's my angle. And -2/3 is adjacent. And by the way, the hypotenuse is always positive, so put the negative in the other spot. Now from that, can you figure out what the y value would be? Do the Pythagorean theorem, you end up getting a √5. Now, I'll never find that angle, but I can take the tangent of the angle. Are y'all seeing that? So what is the tangent of that angle? √5 over -2. So √5 over the -2, and pull the negative to the outside. Are y'all seeing this? I'll tell you what I'm going to do. I'm going to go, like, I'm off second, so I'm going to do a few more of these random problems on here, and I'm just going to post a short little video, and I'll tell you at the very beginning which numbers I'm doing. Like, I'll say, all right, I'm doing, like, 12 or 15 or 17, so if you need more help, I'll do a few more of these so you can see, and you can just kind of flip through that video and see. All right? All right. Is it hot in here to go? All right. Every day I wear a long sleeve shirt, the air conditioning goes off. I'm not kidding, it'll be 76 in here by the end of the day.
We should go to some
The ice? I would love that.
a little ice. No, you.
Like, I have it set on as low as it'll go. It's 72. It's set on 68. I'm not kidding. I wear a short sleeve shirt, it turns into ice box.
It must go lower over there.
This whole wall of rooms has issues. Sadly. All right. Well,